You flip a light switch, and instantly the room fills with light. You see the walls, the furniture, your own hands. It feels immediate. But here's the thing. For the light itself, for the photon that just traveled from the bulb to your eye, no time passed at all. Zero. No time passed at all. Zero. Not a tiny amount. Not a fraction of a second. Nothing. From the photon's perspective, if we can even call it that, it was emitted and absorbed in the same instant. The entire journey to the photon never happened. Now you might think this is just physicist wordplay, some technicality about relativity that doesn't really matter. But Richard Feynman spent years wrestling with this idea, and what he uncovered is so strange, so unsettling, that it forces us to completely rethink what light is, what time is, and whether the universe we experience is anything like the universe that actually exists. Let's start with something simple. You're sitting in a room, and light is bouncing everywhere, off the walls, off your skin, into your eyes. We're so used to this that we don't even think about it. Light just is. It's the thing that lets us see. But Feynman had this habit of stopping and asking, what is this really? Not what does it do, but what is it? And when you start asking that question about light, things get weird fast. Here's the first crack in our everyday understanding. Light moves. We know this. It travels at a finite speed, roughly 300,000 kilometers per second. That's incredibly fast, but it's not infinite. When you look at the sun, you're seeing it as it was about 8 minutes ago, because that's how long it took the light to travel from the sun to your eyes. When you look at distant stars, you're seeing them as they were years, sometimes millions of years ago. So light takes time to travel. That much seems obvious. But now let's ask a different question. What does time feel like for the light itself? If you could ride along with a photon, what would you experience? And here's where Feynman starts to pull the rug out from under us. According to Einstein's theory of relativity, as you move faster and faster, time slows down for you relative to someone standing still. If you're on a spaceship moving close to the speed of light, time on your spaceship ticks more slowly than time on Earth. This isn't science fiction. It's been measured, verified, tested over and over. Atomic clocks on fast-moving planes run slower than clocks on the ground. It's real. Now, what happens if you push this to the limit? What if you could move at the speed of light itself? Well, the math tells us something shocking. Time doesn't just slow down, it stops completely. If you were a photon traveling at light speed, your clock wouldn't tick at all. No time would pass for you, ever, no matter how far you traveled. A photon emitted from a star 1 billion light years away, traveling for 1 billion years from our perspective, experiences zero time. To the photon, the moment it leaves the star and the moment it hits your eye are the same moment. This sounds impossible. How can something travel and not experience time? How can a journey happen if, for the traveler, there is no journey? Feynman loved this kind of paradox because it meant we were brushing up against something deep, something our intuition wasn't built to handle. Let's dig deeper. Feynman's way of thinking about light wasn't abstract. He didn't like vague philosophical statements. He wanted to understand how light actually behaves, what it actually does, and he spent much of his career developing a framework to describe this. It's called quantum electrodynamics, or CAD, and it's one of the most successful theories in all of physics. But the way Feynman explained it, the way he visualized it, reveals just how strange light really is. Imagine you're trying to understand how a photon gets from point A to point B. You might think, well, it just travels in a straight line, right? Light travels in straight lines. That's what we're taught. But Feynman showed that this isn't quite true. According to quantum mechanics, the photon doesn't take one path. It takes every possible path. It goes in a straight line, sure, but it also curves to the left, loops around, zigzags, spirals. Every path you can imagine, the photon explores, all of them, simultaneously. Now, this sounds insane, and Feynman knew it. But here's the kicker. When you add up all these paths, when you calculate their combined effect using the rules of quantum mechanics, almost all of them cancel out. The wild, looping paths interfere with each other and disappear. What's left, the only thing that survives, is the straight line, the path we actually observe. So light does travel in straight lines, but only because all the other paths it takes cancel each other out. Feynman described this using something called the path integral formulation, and it's beautiful in a disturbing kind of way. It tells us that reality, at its deepest level, isn't made of definite events. It's made of probabilities, of all possibilities existing at once, until something forces them to collapse into the one thing we see. And light, because it doesn't experience time, exists in this strange space where all its paths, all its possibilities are equally real until the moment it interacts with something. Here's where it gets even stranger. If the photon doesn't experience time, then from its perspective, there's no such thing as before and after. The emission and absorption of the photon are not separated by time. They happen together. Now think about what this means. When you see light from a distant star, you think of it as a process. The star emitted light a long time ago, the light traveled through space, and now it's reaching you. But for the photon, none of that happened. The star and your eye are connected, not by a journey, but by a single, timeless event. The photon doesn't travel from the star to you. It is the connection between the star and you. Feynman explored this idea in his lectures and writings, and he was always careful to point out that we can't really talk about the photon's perspective in a literal sense. Photons don't have experiences. They don't have a point of view. But the math, the equations of relativity and quantum mechanics force us to confront this reality. For a photon, the universe is fundamentally different than it is for us. And since photons are the things that carry all electromagnetic force that let us see, that hold atoms together, this isn't some obscure edge case. This is central to how reality works. Let's think about this another way. Imagine two events, A and B, separated by space. You're at event A and something happens at event B far away. For you, these events are separate. They happen at different times. But for a photon traveling between them, they are not separate. They are the same event. The photon exists in a reality where the entire history of the universe, from beginning to end, is compressed into a single, timeless now. Every photon that has ever existed, or ever will exist, experiences the universe as a single, instantaneous moment. Feynman once said in an interview that the hardest thing to understand about quantum mechanics is that you can't understand it. You can learn the rules, you can make predictions, you can even use it to build technologies, but you can't picture it in your mind the way you picture everyday objects. And he was right. Our brains evolved to understand objects moving through space and time. We're built to think in terms of cause and effect, of before and after. But light doesn't live in that world. Light exists in a place where time doesn't flow, where all moments are one moment, where the universe is not a process, but a single, timeless structure. Now, here's where Feynman's insights start to connect with something even bigger. If light doesn't experience time, then what does that say about time itself? We think of time as this fundamental thing, this flow that carries everything forward. But maybe time isn't fundamental. Maybe time is something that emerges, something that only exists for objects that move slower than light, for objects that have mass. Photons, which have no mass, don't experience time. They exist outside of it. And if time is something that only applies to certain kinds of things, then maybe time is more like a perspective, a way of organizing experience, rather than the feature of reality itself. Feynman didn't claim to have all the answers to this, but he loved pushing on these questions. In his famous lectures on physics, he talked about how time is deeply connected to causality, to the idea that one thing leads to another, but causality only makes sense if you're moving slower than light. For light itself, there is no causality, no sequence of events, no before and after. There's just the structure, the pattern, the connection. This has profound implications for how we think about the universe. We tend to imagine the universe as a kind of movie, a sequence of frames playing out one after another. But what if that's just our perspective? What if the universe, from a more fundamental viewpoint, is not a movie but a sculpture, a single, unchanging structure where all moments exist at once, and we, because we move slowly, because we have mass, experience it as a sequence? Feynman hinted at this in his explorations of space-time diagrams, where you draw time as just another dimension, like up and down or left and right. In these diagrams, the entire history of a particle, from its creation to its destruction, is laid out as a single path through space-time. It doesn't move through the diagram, it just is. The diagram shows the whole story at once, and for a photon, that path is different. It's a path where the time dimension collapses, where the beginning and end of the path touch. Here's another way to think about it. Imagine you're looking at a photograph. The photograph captures a single moment in time. Everything in the photo exists simultaneously. There's no before or after within the photo itself. Now imagine the entire universe is like that photograph. And we, because of how we're built, because of how our consciousness works, experience it as if it were animated, as if it were unfolding. But the animation is our doing, not the universe's. The universe just is, all at once, and time is the way we read it. This is speculative, of course. Feynman never claimed to have solved the mystery of time, but his work on light, on quantum mechanics, on the strange behavior of photons, points in this direction. And it raises a question that he'd love to ask. What is real? Is the flow of time real? Or is it just how we experience a timeless structure? Is the journey of a photon real? Or is it just our way of describing a connection that exists outside of time? Let's bring this back to the light switch. You flip it, light fills the room. For you, time passes. You see the light. You feel the moment. But for the photons themselves, for the light that just traveled from the bulb to your retina, nothing happened. They didn't travel. They didn't experience anything. They were emitted and absorbed in the same timeless instant. And yet they connected you to the bulb. They carried information. They made it possible for you to see. This is what Feynman uncovered. Light is not a thing that moves through time. Light is the thread that weaves the universe together. And it exists in a realm where time doesn't apply. Every photon is a bridge between events, a connection that ignores the flow of time we take for granted. And because light is what lets us see, what lets us interact with the world, we're always in contact with this timeless aspect of reality. We just don't notice it because we're trapped in time ourselves. So what does this mean for us, for how we see the world? It means that the universe is not what it seems. It means that time, this thing we feel so deeply, this thing that defines our lives, might not be a fundamental feature of reality. It might be an artifact, a consequence of having mass, of moving slowly through the universe. It means that at the deepest level, the universe might be a single, timeless whole, and we're just reading it, moment by moment, like words on a page. Feynman loved the idea that the universe was far stranger than we could imagine, and he spent his life trying to uncover that strangeness. He didn't want to explain it away or make it comfortable. He wanted to stare at it, to wrestle with it, to see just how deep the mystery went. And the mystery of light, the fact that it doesn't experience time, is one of the most beautiful and unsettling things he ever revealed. So the next time you see light, really think about it. Think about the fact that the photons hitting your eyes right now don't experience the journey. They don't experience anything. They exist outside of time, connecting you to the world in a way that defies everything your intuition tells you. And maybe, just maybe, that's a clue that the universe we live in, the reality we think we know, is just the surface. And underneath, something far stranger is going on. What would Feynman say about all this? He'd probably smile, shrug, and say something like, "Isn't it wonderful that we can even ask these questions? Isn't it amazing that the universe is built in such a way that light, this simple everyday thing, reveals something so profound?" And he'd be right, because the more you look at light, the more you realize that it's not simple at all. It's a window into the deepest mysteries of existence. And the view from that window is breathtaking.